Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello, welcome back to the podcast, and if this is your first time, welcome aboard. Either way, I hope you're well. Today we're going on to a new topic. We're going to start talking about kinetics, and in particular today we're going to talk about collision theory. And in doing so, we'll also touch on the topic of activation energy. So first, let's define what we mean by collision theory. What we mean is for a chemical reaction to take place, the molecules that are going to react must collide with each other. Not only must they collide, but between them, they must have enough energy to make the reaction take place. And they must also be orientated correctly for that reaction to occur. It's worth us pointing out that only a relatively small number of collisions between particles will actually result in a reaction. So why is any of this important? Well, it's because the number of collisions that are successful will affect the rate at which a chemical reaction will proceed. So it's really important for chemists to know and understand what the factors affecting the number of effective collisions are and how to manipulate that, how to change the rate of reaction. So what are the things that change the rate of reaction or change the rate at which successful collisions occur? Well, the first one is the temperature. Increasing the temperature of a reaction means that the molecules will be able to move around faster and therefore collide more frequently. It also means that they will have more energy when they collide and therefore are more likely to have enough energy to cause the reaction to occur. In other words, they're more likely to have the activation energy, and we'll come to what that phrase means shortly. The next thing that affects the rate of reaction is the number of particles in a given space. And that can be increased by increasing the concentration of the reactants in a solution, if we're dealing with solutions of reactants, or by increasing the pressure of gaseous reactants, if we're dealing with a reaction that happens in the gaseous phase. Both those situations are going to increase the number of reactant molecules in a given space, and therefore the rate of collisions is going to increase. Similarly, having smaller particles of a solid reactant is going to increase the surface area of that solid, and therefore increase the contact area which other reactants can collide with that solid reactant. So increasing the surface area of our solid reactant will increase the number of collisions that can occur and therefore increase the rate of reaction. Finally, using a catalyst will also increase the rate of reaction. And using a catalyst works by lowering the activation energy for that reaction to occur. The number of collisions isn't increased just by using a catalyst, but the likelihood of a particular collision to result in a reaction will increase, and therefore a catalyst will increase the rate of reaction. Now, we've already mentioned the phrase activation energy a couple of times, and we need to go back and say what we mean by that. We already said that for a collision to result in a reaction, the reactant molecules must collide, they must have the right orientation, and that they must have enough energy between them. And it's that final point, having enough energy between them, that is important here. So that enough energy is the activation energy. If the reactants have the activation energy for this particular reaction to occur, then the reaction can proceed. If they don't, it can't proceed. And when we're talking about activation energy, we often abbreviate that to a capital E and a subscript A. So when you see that, it's referring to the activation energy for that reaction. Okay, let's summarize what we've talked about today. So we mentioned that collision theory is something that governs the rate of reaction. We said that collisions result in reaction if molecules collide with enough energy in the correct orientation. We've said we can increase the rate of reaction by increasing the frequency of effective collisions, and we can do that by increasing the temperature, increasing the concentration of reactants in solution, increasing the pressure of gaseous reactants, increasing the surface area of solid reactants, and by using a catalyst. We've also said that activation energy is that minimum amount of energy that is required in a collision for a reaction to take place. And that if there isn't enough energy there, if the reactant molecules don't have between them the activation energy, the reaction cannot occur. Okay, so if you have any further questions on this particular topic, please do get in touch. I do like to hear from you. The best place to do so is over in our Patreon community at patreon.com/chemistry made simple. Be great to hear from you there. You can also find me on Instagram at chemistry made simple, and you'll find links to both Patreon and Instagram in the episode description below. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistry made simple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.